Hello, hello and welcome to this video. In this video, we will continue our read through of functions and operators chapter of PostgreSQL. If you have not watched previous videos, I would strongly recommend that you watch the practical video which we did, the two videos we did, second last from this one, not second last, third last and fourth last. So please watch those videos because a lot of that which was explained in those videos will not be explained here. So we will start from the substring function. Let's start the read through. The substring function with two parameters, substring string from pattern, provides extraction of a substring that matches a POSIX regular expression pattern. It returns null if there is no match. Otherwise, the first portion of the text that matches the pattern. But if the pattern contains any parenthesis, the portion of the text that matches the first parenthesized sub-expression, the one whose left parenthesis comes first, is returned. You can put parentheses around the whole expression if you want to use parentheses within it without triggering this exception. If you need parentheses in the pattern before the sub-expression, you want to extract, see the non-capturing parentheses described below. So we have toolbar and we are selecting O.P. So dot matches any character and therefore it will match this. Then we are matching dot here. So like we read, it will match this O, the middle O between O and B. The regex count function counts the number of places where a POSIX regular expression pattern matches a string. It has the syntax regex underscore count, string comma pattern, then optional arguments are start and flags. Pattern is searched for in string normally from the beginning of the string, but if the start parameter is provided, then beginning from that character index. The flag parameter is an optional text string containing 0 or more single letter flags that change the function's behavior. For example, including I in flags specify case insensitive matching. Supported flags are described in table 9.24. So we are matching, we are counting this regular expression capital A dot. So it will match the AB and then AB and then AX. It will not match this because it is case sensitive match. But if you start at position 1 and then you put I flag, it triggers case insensitive match. So it will match 1, 2, 3 as well as small a and x. The regex underscore in str function returns the starting or ending position of the nth match of a POSIX regular expression pattern to the string, or 0 if there is no such match. It has a syntax regex underscore in str. String pattern are mandatory argument, then we have start, then end, and then end option, followed by flags and sub-xpr. Pattern is searched for in string normally from the beginning of the string, but if the start parameter is provided, the beginning from that character index. If n is specified, then the nth match of the pattern is located, otherwise the first match is located. That is, default value of n and start are 1. If n is, sorry, where was I? Okay. If the endpoint parameter is omitted or specified as 0, the function returns the position of the first character of the match. Otherwise, end option must be 1 and the function returns the position of the characters following the match. The flags parameter is an optional text string containing 0 or more single letter flags that change the function's behavior. So again, it is described in 9.24. For a pattern containing parenthesized sub-expressions, sub-xpr is an integer indicating which sub-expression is of interest. The result identifies the position of the substring matching that sub-expression. Sub-expressions are numbered in the order of their leading parentheses. When sub-xpr is omitted to 0, the result identifies the position of the whole match regardless of the parenthesized subexpression. So we have the string number of your street, comma township, comma fr. Then we are looking for this pattern starting from beginning and comma. It is negation of comma and then plus one or more. It starts at 1 and then a value of n is 2, and then end option is 23. Okay, sorry, end option is not 23. 23 is output. So I guess it is counting all the characters ignoring comma. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. So the comma, it will match up here. So that is why this is 23. Then we have string A, B, C, D, F, G, H, I, and we have a pattern here. C double dot and then triple dot. Starts at 1, n is equal to 1, end option is 1, flag is I, sub expression is 2. So it will match ABC, it will match C, D, E, and then F, G, H, I. So that's why the count is 6. The regex underscore like function checks whether a match of POSIX regular expression pattern occurs within a string, returning boolean true or false if the syntax regex underscore like string comma pattern comma flags. Again, flags is the same thing. This function has the same result as the tilde operator if no flags are specified. If only I flag is specified, it has the same result as the tilde star operator. I play games as well, so I was installing Dota. Alright, so some examples are given here. Regex underscore like hello space world, and we are looking for world. This is a case sensitive match, so it will not match the world. Then we have hello world, we match with the world again, but this time it is case sensitive match, and it matches the regular expression. The regex underscore match function returns a text array of matching substrings within the first match of a POSIX regular expression pattern to a string. It has a syntax regex underscore match string comma pattern comma flags. If there is no match, the result is null. If a match is found and the pattern contains no parenthesized subexpressions, then the result is a single element text array containing the substring matching the whole pattern. If a match is found and the pattern contains parenthesized subexpressions, then the result is a text array whose nth element is the substring matching the nth parenthesized subexpression of the pattern, not counting non-capturing parentheses. See below for details. The flags is the same thing. So we have foo bar bouquet badge. So it will match bar dot star q. So bar and then dot star q, it will match this position as well. So dot star will match BE and then Q will match this. So this much was selected. Then we have bar BQ, so it will match bar and then it will match BQ. So both elements will be in the array. In the common case where we just want the whole matching substring or null for no match, the best solution is to use regex underscore substr. However, regex underscore substr only exists in PostgreSQL version 15 and up. When working in older versions, you can extract the first element of regex underscore match result. So for example, you do regex match and then you give the array 1 and it will give you the match. The regex underscore matches function returns a set of text arrays of matching substrings within matches of a POSIX regular expression pattern to a string. It has the same syntax as regex underscore match. This function returns no rows if there is no match, one row if there is a match and the G flag is not given, or n rows if there are n matches and the G flag is given. Each returned row is a text array containing the whole matched substring or the substrings matching parenthesized subexpressions of the pattern. Just as described above for regex underscore match. Regex underscore matches except all flags shown in the same thing. It's the same G. So we are matching the foo with not there. Of course, it won't match. Then we have this foo bar stuff. Then we are looking for word boundary negating B. Okay. And we are looking for, this is not word boundary, we look for B and then followed by non-B characters, one or more. Then the same thing, and we are capturing it this time, we are capturing both. So if you look, this bar will match because this B will stop matching. We are negating B, so bar is the first one. And then this one will match BQ here. This is the second match. Then Basil is the third match. And then barf is the fourth match. Okay. So this is how it works. Okay. So verbally, yeah, this one. In most cases, the regex underscore matches should be used with the G flag. Since if you only want the first match, it is easier and more efficient to use regex underscore match. However, regex underscore match only exists in PostgreSQL version 10 and up. When working in older versions, a common trick is to place a regex underscore match is called in a subselect. For example, select call comma select regex underscore matches call one. This is call one. This is call two. Barbecue from tab. This produces a text array if there is a match or null if not, the same as regex underscore match would do. Without the subselect, this query would produce no output at all for table rows without a match, which is typically not the desired behavior. The regex underscore replace function provides substitution of new text for substring that match POSIX regular expression pattern. It is a syntax regex underscore replace string pattern replacement, comma flags. We have already seen all these functions in the previous videos, so we are just going to read through it. Or the second variation of this function is string pattern replacement start n and flags. The source string is returned unchanged if there is no match to the pattern. If there is a match, the string is returned with the replacement string substituted for the matching string. The replacement string can contain \n where n is 1 through n to indicate that the source substring matching the nth parenthesized sub-expression of the pattern should be inserted, and it can contain \ampersand to indicate that the substring matching the entire pattern should be inserted. Write double backslash if you need to put a little backslash in the replacement text. Pattern is searched for in string normally from the beginning of the string, but if the start parameter is provided, then it's the same discussion start and end. It's the same thing, and the flag is also the same. So certain things repeat in documentation again and again. So we have foo bar bars, and we are matching with b dot dot, and this one would be replacement, right? So it will match bar here, okay, and that will be replaced by x. That is the first match, so it will be replaced. Then we have foo bar. Now the flag global is given, so it will match bar and bars twice, and therefore it will be xx. Then we have b, and then we have bracket dot dot, and we are replacing with x \1 y. So it will replace this, and then it will take the captured group here. This is the captured group which is referenced as \1. So b will be replaced with x, and then ar will remain same, and then b will be replaced with then y will be inserted, and then b will be replaced with x, and az will be replaced with the match. It will won't be replaced, it will just come as \1, and then y will be put at the end. Then we have a PostgreSQL function, and we look for vowels and replace them with x, and starts from 1, and 0 is 0 would be start and n. So starts at n, and n, what was n? If n is specified and is greater than 0, so it does not work because it is 0. So here A will match, case sensitive match is there. So A will be replaced with X, then O, then E, then U, then C, and not C, then U, and then I and O. So those will be replaced with X. Then we have this string and we have this pattern, and n is equal to 3 this time, so it will skip, it will start at position 3. So this O and this A will not be replaced. So it will replace only here. I think n is the count here. N is the count. For 3 characters it is looking for. I get confused. So let me look at this replacement text, start 1 and 3. Start is fine. If nth match of the pattern is replaced, okay, nth match of the pattern will be replaced. The first match is A, then second match is O, and the third match is E. So E will be replaced here by X. The regex split to table function splits a string using a POSIX level expression pattern as a delimiter. It has the syntax regex underscore split to table string comma pattern comma flags. If there is no match to the pattern, the function returns the string. If there is at least one match, for each match it returns the text from the end of the last match or the beginning of the string to the beginning of the match. When there are no more matches, it returns the text from the end of last match to the end of the string. The flags parameter is an optional text string containing 0 or more single letter flags that change the function's behavior. So the flags are again described in 9.24. The regex split to array function behaves the same as regex underscore split to table, except that regex split to array function returns its results as an array of text. It has a syntax regex split to array string pattern flags. The parameters are the same as for regex split to table. So we have split to table, and the word is the quick brown fox jumps over the lazy dog, and our pattern is backslash s plus, that is white spaces. So every word will be broken down into individual element, and we have the table, the quick brown fox jumps over the lazy dog. Now we are splitting the same thing to an array, so it will come as an array in the output. Then we have the quick brown fox, and our delimiter is white space but with star. That means 0 or more, so all characters will be split and this space will be removed here. So it is THG, QU, and so on, it comes. Okay. As the last example demonstrates, the regex split function ignores zero length matches that occur at the start or end of the string or immediately after a previous match. This is contrary to the strict definition of regex matching that is implemented by the other regex function, but is usually the most convenient behavior in practice. Other software systems such as Perl use similar definition. The regex sub-str function returns the substring that matches the POSIX regular expression pattern or null if there is no match. It has the syntax regex underscore substr string pattern start and flags sub-str. Pattern is searched for in a string normally from the beginning of the string, but if the start parameter is provided, then beginning from that character index. If n is specified, then the nth match of the pattern is returned. Otherwise, the first match is returned. The flags parameter, give me a moment. So if n is specified, then the nth match of the pattern is returned. Otherwise, the first match is returned. The flags parameter is an optional text string containing 0 or more single letter flags that change the function's behavior. Supported flags are described for a pattern matching for a pattern containing parenthesized sub-expression. Sub-xpr is an integer indicating which sub-expression is of interest. The result is the substring matching the sub-expression. Sub-expressions are numbered in the order of their leading parentheses. When sub-xpr is omitted or zeroed, the result is the whole match regardless of parenthesized sub-expression. So again, we have number of your stage count 0, okay, and we are looking for one or more characters except comma. So it will first match this, okay, And remember our start is 1. Okay, so it will start at 10. And 2 means the second match. The second match will be township. So that's why we have township here. Now we have start is equal to 1 and we are looking for the first match, case insensitive. And what was 2? Let me moment. This is sub xpr2 is it we are looking for. We are looking for this. So C dot dot will match CDE and then C dot will match SPH. So we will stop here, and in the next video we will continue with regular expression details. So I hope that you are finding this video useful and informative. And if you have not gone through the entire playlist, it is important that you go through the entire playlist. There is quite a bit of information there. And I will end this video here. If you have any questions or comments or feedback to me, then please make use of comment box and tell me what you think. Your feedback is important to me. And if you have any requirement of any other videos on technology, let me know what do you need videos on, and if I know that, I will be happy to make videos on that. So thanks a lot for watching the video, and we will meet again tomorrow with more read through, that is the next section, regular expression details, and we'll continue from there. So once again, thanks a lot for watching the video. Keep learning and enjoy.